Hi, in this demo, I'll present how SkyDRM secures large language models, LLMs, running locally. Powered by a zero-trust unified policy server and patented Dynamic Authorization policy engine, SkyDRM, NextLabs Enterprise Digital Rights Management, E-DRM, restricts local LLM on Windows to authorized users and trusted applications, and protection travels with each model wherever it goes. Let's first understand how we can enjoy the benefits of local LLMs without risk. Running LLMs locally has become very popular, and for good reasons. It offers real benefits: privacy, full control over data, no per-token usage costs, and the ability to work offline. However, running an LLM on one's own machine also introduces new security risks. The model files can be deleted, modified, replaced, or copied by unauthorized users or applications. This creates opportunities for malicious models that can trigger code execution, ship with backdoored weights, amplify prompt injection attacks, and ultimately damage the organization's reputation. This is where SkyDRM closes that gap. It protects local LLM on Windows by restricting access to authorized users and trusted applications only, so the models stay safe wherever they go. When an LLM file lives on an endpoint without protection, 5 things can happen. Local LLM can be accessed by unauthorized applications. Any process on the box can load them and feed them prompts. Local LLM can be replaced with malicious versions. An attacker swaps a trusted model file for a backdoored one. Local LLM can be modified by unauthorized users, subtly changing weights or configuration in ways that are hard to detect. Local LLM can be copied or moved off the device entirely, exfiltrated to a USB drive, a cloud folder, or another machine. Local LLM can be deleted by unauthorized users, wiping out a model you depend on. In this demo, I'll demonstrate what can happen to a local LLM when it isn't protected, and how SkyDRM locks it down. The model I will be using is DeepSeek R1 Distill Qwen 7B, in GGUF format, running on my Windows machine. I have 2 local LLM applications installed, LM Studio and GPT-4all. Let's start by seeing what an attacker or any unauthorized user or application can do today without SkyDRM in place. Here is the model file on my machine. Notice the folder path. This is the standard LM Studio models directory. First, let's confirm everything works as expected. I'll open the LM Studio and load the model. As you can see, the model is loaded successfully. Now, let's send a few prompts to test if the model works. The model works as expected, and LM Studio can use it normally. Now, let's review the first problem. Suppose GPT-4all has not been approved to use this model. Even so, because the model file is simply stored on disk without any protection, there is nothing preventing GPT-4all from accessing it. Now, let's attempt to load the model in GPT-4all and send a few prompts. As you can see, GPT-4all is able to load the model and generate responses successfully. In fact, any application on this machine can open and use the model. That includes applications installed without IT approval, as well as potentially malicious software. Although the model is intended to be controlled and governed, it's effectively available to anything that can locate the file. Now, let's simulate an even more serious attack. I prepared a different model file with the same name, DeepSeek R1 Distill Qwen 7B Q4 _0.gov, but with different contents. In a real-world attack, this could be a backdoored model, a model with poisoned weights, or one with hidden prompt injection behavior. I'll place it in the folder and replace the legitimate model file. As you can see, there's no warning, no block, and no audit trail. The legitimate model has been silently swapped out, and neither the user nor the organization has visibility into the change. Now, let's go to the LM Studio and load the model. The model loaded successfully. Let me send a prompt here. From LM Studio's point of view, nothing has changed. The model has the same name and same file path. However, the underlying file is completely different. In the real-world attack scenario, the user could continue interacting with the model without realizing that the trusted model has been silently replaced. Replacement, in fact, isn't the only attack. The model file itself can also be accessed and modified by unauthorized tools. Now I will show you something simple using Notepad++. Let's make some minor adjustments to the file by replacing datetime with date. As you can see, there is nothing preventing the file from being modified. Depending on what is changed, the model could fail to load, generate incorrect responses, or introduce subtle behavioral changes that are difficult to identify. The next risk is exfiltration. Models like this represent valuable intellectual property and significant investment. Without proper protection, they can be copied and moved without authorization. Let's see how easy it is to extract a model from the local machine. We will copy the model file and paste it onto the local disk. The copy is complete. The model is now portable and can be carried off on a USB drive, uploaded to personal storage, or shared with unauthorized parties. Finally, there is a risk of deletion. Here, let's attempt to delete the model file. As you can see, the file has been removed successfully, with no warning or control preventing the action. Without proper protection, an unauthorized user, script, or malicious application could delete the model file, disrupting access to the model. This could result in the loss of a model that required significant effort and resources to acquire, configure, and maintain. Each of these risks represents a significant security concern on its own. Together, they highlight the broader challenge of running local LLMs without proper control. This is the challenge we are going to address. Now let's see how SkyDRM addresses these risks and secures local LLMs on Windows. SkyDRM addresses these risks with three capabilities working together. First, SkyDRM Desktop for Windows is the agent that runs on each Windows endpoint where local LLMs live. It enforces protection policies on the device. Second, SkyDRM provides a sanctuary folder. Any LLMs placed inside the sanctuary folder is protected. Unauthorized users cannot access, modify, replace, or delete those models. And here's the important part: if a model is ever copied or moved out of the sanctuary folder, it is automatically protected by a predefined rule. So, protection follows the file, inside or outside the folder. Third, SkyDRM uses a trusted application list. Only approved Windows applications, those explicitly designated as trusted, can open the LLMs in the sanctuary folder. All other applications are blocked, regardless of who is logged in. Before we run the demo, here's the demo setup. On the NextLabs software, we have SkyDRM RMS, which is the central rights management that holds policies and protection rules. And SkyDRM Desktop for Windows, which is the endpoint agent on the demo machine. For classification, we're using the Category S classification with the label Secret. We will demo with two Windows applications, LM Studio and GPT-4All. The sanctuary folder is located in the LM Studio Models directory, and the rule is set to protect any file labeled Secret when it's copied and moved out of that folder. In summary, the LM Studio is configured as a trusted application, while GPT-4All is intentionally left unconfigured, so it's treated as untrusted. Now, let's run the following command to configure the folder as a sanctuary folder. In the first use case, we will see how to secure local LLMs on Windows without a SkyDRM login. For example, an attacker, another user on the machine, or any process running without a valid SkyDRM session. In this state, LM Studio and GPT-4All cannot detect any existing LLM in the sanctuary folder, and users cannot access the sanctuary folder. Let's move into the demo. I'll launch LM Studio while no user is logged into SkyDRM. As you can see, LM Studio launches but cannot detect any existing LLM in the sanctuary folder. The model list is empty. Even though there are several models on disk in the sanctuary folder, LM Studio simply cannot see them. SkyDRM is blocking the read at the file system level. Now, let's open GPT-4all. Similarly, GPT-4all cannot detect any models. Let's attempt to install a model. We will select a model from the File Explorer. Let's navigate to the sanctuary folder and attempt to open it. As you can see, when I try to open the model, an access denied message pops up, indicating that I do not have access to the sanctuary folder. This provides a security boundary. Without a valid SkyDRM login, access to the models is completely blocked. No application can open, modify, or access the protected model files. Now, let's look at the next use case on securing local LLMs on Windows with a SkyDRM login. In this use case, we will demonstrate the following. LM Studio, which is a trusted application, can load and run LLMs in the sanctuary folder. GPT-4all, which is an untrusted application, is blocked from loading any LLM in the sanctuary folder. Authorized users can create, delete, copy, and move files within the sanctuary folder, and open or modify them through trusted applications. And any file copied or moved out of the sanctuary folder is automatically protected by SkyDRM, so security follows the file. Now let's log into SkyDRM Desktop for Windows as an authorized user, John, and see how the experience changes for authorized users. Let's open LM Studio. Since LM Studio is on the trusted application list and I'm signed in as an authorized user, the models are fully available. Let's load the DeepSeek R1 Distilquin 7B model, which is from the sanctuary model. The model is loaded successfully, and I will attempt to send a few prompts. As you can see, the responses are generated successfully. Now let's open GPT-4all, an untrusted application, and try the same thing. Let's attempt to install a model. As you can see, the model cannot be loaded because GPT-4all is not on the trusted application list even though John is an authorized user. This prevents a malicious or compromised application from leveraging an authorized user session to access protected models. Next, let's manage files in the sanctuary folder. We will copy a PDF file from the local disk folder to the sanctuary folder. As you can see, the folder is successfully added to the sanctuary folder. Then, we will attempt to delete the PDF file. The file is deleted successfully. This is as expected since John is an authorized user and is permitted with these controls. Now, I will create a new folder on the local disk and name it. Let's attempt to copy a model from the sanctuary folder into this new folder. Let's verify the file information using SkyDRM View File Info. As shown here, the file's S classification is secret, and the assigned permissions include full control along with a watermark condition. This confirms that when the model leaves the sanctuary folder, SkyDRM automatically applies to the secret label and associated protection policies. As a result, the file remains protected even after it has been copied outside the sanctuary environment. This addresses the exfiltration risk demonstrated earlier. Even if a model file is copied to a USB drive, uploaded to external storage, or shared outside the organization, the protection remains with the file. Anyone who receives the model must still be authorized before access is granted. To summarize, without a SkyDRM login, the LLM in the sanctuary folder are completely inaccessible. No application can load them, and no user can access them through the file system. With a SkyDRM login, authorized users can access the models through trusted applications with a seamless user experience. Untrusted applications remain blocked, even when used by authorized users. When a model leaves the sanctuary folder, SkyDRM automatically applies protection policies, so security remains attached to the file wherever it goes. This is how SkyDRM enables organizations to benefit from local LLMs, including privacy, data control, offline access, and reduced usage costs, while protecting valuable model assets from unauthorized access, modification, and exfiltration. With this, we conclude our demonstration on securing LLM locally with SkyDRM. Thank you for watching. If you're interested in learning more about SkyDRM and other NextLabs data-centric security solutions, please subscribe to the NextLabs channel and stay tuned for other videos on the topic.